Hello guys, so if we have our function z being equal to f of uvw, then the total differential dz is given by getting the sum of the partial derivative separately. So as you can see here, we're evaluating partial derivative of z with respect to u, then multiplying with straight du, plus partial derivative of z with respect to v, then multiplying with a straight dv, then partial derivative of z with respect to w, then multiplying with a straight w. So if you're given an example, let's say we have our example 1, you're being told z is equal to x squared y cubed plus 2x over y, and then you're being told to get the total derivative dz. So how do you go about getting dz? So first of all, look at z. It is written with respect to two variables, that is x and y. So meaning the total differential will be given by partial derivative of z with respect to x multiplied by a straight dx plus partial derivative of z with respect to y multiplied by a straight dy. So evaluating that, what do we get? So we have coming to get the partial derivative. So partial derivative of z with respect to x, look at z. Partially differentiating it with respect to x, meaning y is acting as a constant. So here differentiating this, we will have 2xy cubed plus differentiating this with respect to x, y is acting as a constant. So our answer will just be 2 over y. Then multiply all this with dx plus, now we evaluate partial derivative of z with respect to y. So with respect to y, x will be acting as a constant. So differentiating this, we will get 3x squared y squared plus differentiating this with respect to y, we can be able to rewrite this as 2xy raised to power -1. So differentiating it with respect to y will be minus. So we'll have minus 2xy raised to power -2. Okay, all this multiplied with a straight dy. And that's how we go about getting total differentials. We could take up another example, example number 2. You're given z is equal to 3u squared minus 2v plus 4w cubed v squared. And then you're being told to get dz. Now, z is written with respect to u, v, and w. So the total differential of z will be the sum of their partials. So we will have partial derivative of z with respect to u multiplied with a straight du, partial derivative of z with respect to v multiplied with a straight dv, plus partial derivative of z with respect to w multiplied with a straight w. Okay, so let's go on into evaluating for the partial derivatives. So we have partial derivative of z with respect to u. We are going to differentiate the whole of this z with respect to u, meaning v and w will be treated as constants. So let's start with this first term here. With respect to u, the derivative will be 6u minus, with respect to u, this will be a constant. Differentiating it will get 0. With respect to u, we don't have u here. So the whole of this is a constant, we get 0. So we have 6u du plus, now differentiating z with respect to v. With respect to v, this is a constant, it does not have v, so the derivative will be 0. With respect to v, here we will have minus 2. With respect to v here, we will have, so look at this, 8w cubed v, and multiply this with dv plus, differentiating now with respect to w, v and u will be treated as constants. So this will give us a 0. This will also give us a 0. So differentiating with respect to w, this will give us 12w squared v squared dw. And this is basically our answer when we evaluate. Final example, let's say you have your Z is equal to, so example number 3, Z is equal to X cubed plus Y squared. And then you need to get total differential dz. So z is written with respect to two variables, that is x and y. So the total differential will be their partials, dz dx multiplied by straight dx plus dz dy multiplied by straight dy. Okay, so evaluating the partials, we have the partial derivative of z, the partial derivative of z with respect to x, y will be treated as a constant. So differentiating that, will get 3x squared plus 0, because this will be a constant, dx plus partial derivative of z with respect to y, x will be treated as a constant. So this differentiating will get 0. Then we have 2y dy. Finally, we have our z as, our z is equal to 2xy minus cos x. Then what's the total differential? Z is written with respect to two variables, that is x and y. So the total differential will be given by the sum of their partials. So dz dx straight dx plus partial derivative of z with respect to y straight dy. So that's what is going to give us our answer. Now evaluating the partial derivatives. So we have partial derivative of z with respect to x, y will be treated as a constant at this instant. So differentiating this with respect to x, we have 2y, okay, minus differentiating cos x with respect to x, we have minus sine x dx plus partial derivative of z with respect to y. So x will be treated as a constant. This will give 2x because the derivative of y is 1. So we have 2x differentiating with respect to y. Since we don't have y here, the whole of this will be a constant, that will give us 0 dy. So basically that's how we go about getting total differential.